Hello guys, my name is Rusidi. I'm going to talk about postfig. As you can see here, I already done the postfig, but how I did it. Firstly, you must know what is BODMAS. BODMAS stand for B for bracket, O for off, I guess, D for division, M for multiplication, A for addition, and S for subtraction. Okay. If you take a look at the program execution expression, Z equals to open bracket A plus with C, then multiplication with D, close the bracket, subtract, open bracket again, F divide B, subtract with A, and lastly close the bracket. Okay, the important thing about postfig is you cannot arrange the expression using BODMAS. You have to do from the left to the right. Like, you can't put C multiplication with D. I know the multiplication is way better, like more powerful than addition, but you can't put C multiplication with D after equal to Z. You must start with A. After that, you can put multiplication and addition using BODMAS, as you can see here. Okay. One more thing about postfig. If you already did wrong at postfig, all the address and stack diagram will be wrong too. So you must be careful when using postfig, when doing postfig.
Hello, my name is Muaz bin Abdullah, and today I will talk about zero address in stack diagram using this expression. As you can see here, we got Z equal to A plus C times D minus F divided by B minus E. So this is the stack diagram for zero address. This is the zero address execution. As you can see here, push A, push C, push D, multiply and add. Why? First, we will push A and then push C and then push D. Push A, push C. The next, we will keep pushing upwards, and then we will do the multiplication first, as in BODMAS, multiplication is more prioritized. And then after we multiply the C and D. Thus we get C times D. And then we add another execution instruction. We will add, and then we will add A and C times D. Next, we will push F, push B, division, push E, and subtract. As you can see here, F and B, but we didn't exactly push all the way until E. We push F and B first because we want to do division, and then we push E to subtract. So we will push F, push B, and then we divide. So we get F divide B. Next we push E, and then we subtract. F and B will subtract above. Anytime we will get an instruction, it will always beginning with the bottom part and then subtract the upper part. So we will get F divide B minus E. Last one is we will subtract. So that's why we leave this one at the bottom. So we will subtract A plus C and D, subtract F divide B minus E. So we will get our whole expression. Next, I will talk about how to use one address. First, we use only one address. We will load C, D, and store in X. So we will load C into accumulator, AC. This is our instruction. And then we multiply with D. So we keep adding it into the accumulator. So AC we put into AC. We multiply with D, and then we store AC into X for temporary address. Next, we will load A as here into AC, which is accumulator. and then we add x. So AC, which is previous one is A, as you can see here, this is A inside here, and then A will plus with x, as it A C E S x that we have before is C times D here, because we store x with C times D. And then after we add it, we will get A plus C times D. We store again in x, because we want to subtract the next expression. We load F. We put after we store in x, AC will be empty. So we store back. We can use AC back. We can put F inside AC. We will divide B. So we use AC. We put AC divide B. So this AC contain F. So F divide B. Next, we keep continue. We subtract with E. So this AC contains F divide B. F divide B minus E. We get this whole expression. We store again in temporary address in Y. We store in Y, and then we combine these two expressions, left and right, with a subtraction in the middle. We load X, which is before. This whole expression is now X, this whole is Y. So X minus Y, X minus Y. So X minus Y, since before we put AC in X, so AC, which this one contain X minus Y, we pull it back in AC, and then we pop out the Z. We put all the things that we have in accumulator into Z, which is store Z. Next is to address. Okay, the to address is much simpler. So we no longer use accumulator. We straight away use a temporary storage, which is X. So we will store in X. We start it from behind this time. So X equal F, and then we divide X. So we store X. We store F in X. So we divide X with B, because this contains F now, and then we subtract X, which X now contains F divide B, and then we might subtract with E. So we leave it. So now our X contain all of this. Next we will continue with Z. Z is now equal. We will load C, and we put in C in Z. And then in Z now we have C, so C times D, and then we add Z and A into A. Z right now have C times D, so C times D plus A. And then lastly, we subtract all of this, because this is Z, this is X, and then we keep it in Z. So Z in Z minus X. Then we have our whole expression.
Hey, it's me, Rose again. So now I'm gonna talk about tree address. Tree address is only use formula and tree execution at the same time. I will show you how. Oh yeah, when doing tree address, it doesn't matter if you do the front first or at the back first, as long as it's equal to the power of the board mass, like I have talked about just now. Okay, let me show you how. But firstly, Z for the first row is where to store and the 2 at the back is where the expression is. Like divide Z F B equal to like Z equals to F divide B. Then subtract C Z E. Z equal to F divide B, then subtract E. Multiplication X C D, like X equal to C multiplication D. Addition X A X. X equal to A plus C and multiply D. And lastly, subtraction Z X Z. Z equal to F divide B, subtract E, then subtract again A plus C, then multiply D. As you can see, this is the postfix, right, of the expression here. And before I forget, the less you make the tree address, the better address it will be. Okay, so that's all for today. Thank you for watching.